Integration is taught, right? How to variable force work done we have solved already. How we do? Work done equals to integration fx dx, right? Plus integration fy dy. From where to where? x1 to x2. X is changing from where to where? 2 to 3. And y is changing from 3 to 0. Okay? Final is 0. Final is 3, 0. Okay? Integrate this. Here 3x dx and here 4 dy. That's it. So this will come whatever 4 into minus 3. Okay? 3x dx. So 3 into x square by 2. Limit is 2 to 3. Plus here what we will put? 4 into y. Limit is 3 to 0. What you will put? 3 into 9 by 2 minus 2. 2 square by 2 na? Plus 4 into 0 minus 3. 9. Block of mass and strike to a string is lowered by a distance d at a constant acceleration g by 3. The work done by the string is basically work done by the tension. Okay, so tension force is upward. So coming down with the g by 3 acceleration. So tell me, like this something, string is there, okay, mass is hanging. Instead of, if you cut the string, you will go with the g, but he's going with g by 3, means you are holding with some tension upward, but he's going down. So if you see here tension T upward and here mg downward and going with what acceleration? G by 3. So net force equals to mass into acceleration, valid. So we can say mg minus tension equals to m into g by 3. Tension came how much? 2 mg by 3. Okay. This is mg by 3 this side, T this side. Okay. 2 mg by 3 tension. Displacement is which side? This side. D displacement, force is upward, so work done negative. Force into displacement with a minus sign. Okay, cos 180 na? Displacement downward, force upward. 11th question. Block of mass m is pulled along a horizontal surface while applying a force at an angle theta with the horizontal. If the block travels with a uniform velocity and has a displacement d, the coefficient of friction is mu, then the work done by the applied force is. Going with the constant speed means net force 0, means friction is balancing what? This F force, right? So if we see this question we have already done, just little bit extra is there something and then you didn't able to do. In the exam like this only question will come. Maybe some questions will not match exactly, but concept will be same only. So here we have done this thing many times. We applied force like this also, like this also, like this also. So it came this one. Okay. How much angle? Theta. This side force F sine theta. This side force F cos theta. Upward normal. Downward mg. This side friction. Right? Which friction will act? Static friction. Moving with constant velocity. Static friction. Kinetic. How much? Mu into normal. Right? So first get the normal in vertical direction. How much? Upward force normal plus F sin theta, downward mg. So n plus F sin theta is what? Mg. So normal came how much? Mg minus F sin theta. Here in horizontal, this forces should balance, right? So F cos theta should balance what? Mu into normal. Normal is mg minus F sin theta. Understand? Okay. From here, what he is asking? He is asking the work done by the applied force if he moves d distance. If this moves d distance this side, okay? Force F is this side. So what is the work done? First you tell me. F d cos theta. Right? From this equation get the F. Put it here. Answer came. How you will get the F? Multiply it inside. Bring this quantity that side, take common F. I will only tell because calculation also will not do, don't know how to do, right? F, this cos theta is there, and from here mu into sin theta will come with this side positive, right? So then cos theta plus mu sin theta, divide that side. So mu mg by cos theta plus mu sin theta. This will come F, put it there. Answer came. Okay? That's it. 13. Block of mass M is taken from A to B under the action of a constant force provided by this force. F into distance moved R. OB is how much? R. Right? That's it. F into R. Force F into R. If this have been like this, tell me. If this have been like this we did one question in your module only previously. The block was here. The block came from here to here. What is the velocity of the block like that he asked? And then you solved. There were two forces acting. There is a gravity and there was F force this side. How you solve this question? Work done by gravity, mg into r. This was quadrant 1/4, right? This is r, this is r. So this side work done, mg into r. And this side work done, mg into r, this side f into r. Because this is like a force only, na? Constant force in the same direction. How you write down mg this side? Constant force, continuously in the same direction. So force into displacement total, vertical displacement. Similarly here force is this side, displacement r this side. Similarly this question, okay, this side displacement is how much? OB. OB is what? R. So F into R is the work done. Okay, that's it. Like a gravity only. Gravity act downward, he acts this side. That's it. Constant force. 14th. Zero na? Because if you consider any pendulum, okay, any pendulum with respect to trolley, this is pendulum hanging, okay, from the roof. If he moves, he will move like this, right? Right now, if he moves like this, every single point of time when he is here, his tension is this side, perpendicular to his displacement. So he will follow a circular arc, right? So tension work done 0 because force is perpendicular to the displacement. This we will study in circular motion, vertical circular motion. That work done by the tension force is 0. Why? Because it is always perpendicular. Okay. 16. From v equal to 0 started and reached u speed in t1 time with a constant acceleration a, let's say. Okay. Can we get the a? V equals to u plus at. So a is what? U by t1, right? U by t1. This is the acceleration, correct? Mass into acceleration is what? Force. Okay. So force came how much? M into a. That a is what? Mu by t1. This is the force. Force into displacement. So in t time, starting from 0, but in t time, how much is the displacement? S equals to ut plus half at square, right? So S is what? Ut that is 0, half a t square. Here till t time he is asking. So this is a constant force into this is the displacement. Multiply, answer here. A value we can put from here u by t1. So this is half u t square by t1. That's it. Okay. 17 v square. Half and v square is the energy. He bullet gone and stopped. Right? That means whole kinetic energy lost. Lost in what? Heat. And he's saying half of this energy is converted into heat. Means half of this converted into heat. Means okay. Rise in temperature, so bullet specific heat. Specific heat, then mass should be given. Na? Okay, mass will get cancelled out. Ms delta T. But there is one more thing missing. This S is given in calorie per kg. Okay. So there is something called as J, mechanical equivalent. Mechanical equivalent. Okay. J, you know, 4.2. 4.18 actually. Use 4.2. You know that thing? What is J? 4.2 joules per calorie. Okay. So this specific heat is in calories, right? But this half mv square, calorie per joule? No, na? I know. Half mv square is in joules, right? Specific heat S is in calories. So you have to convert this calories into joules. See here, just simply see here, joules is the unit. Okay. Either you convert this joules into calories or convert this calories into joules. Okay. So to convert this joule into calorie, what you have to divide? So you have to divide with J or you have to multiply. Like this, I am saying that. Let's write down on the next page. I will clearly write down. With units. Here you have half mv square is half energy. Means this is in joules. Okay. Okay. This is equals to ms delta T. M mass is in kg, which will get cancelled out, but still write down. M kg. Specific heat unit, you know. Specific heat is given in calorie per gram or kg? Kg, na? Kg degree centigrade into delta T. Delta T is also in degree centigrade. If temperature difference is there, you put it in Kelvin or degree centigrade, doesn't matter. Actually, it should come in Kelvin, but it will not matter if it is a temperature difference. Okay? Why it will not matter? We will explain, or if you understand, very good, right? So this is the thing. Okay? Now if I see here, degree centigrade cancel out. Okay? And kg cancel out. Here calories and here joules. Can't be equated. So J will be there. Now we understand that J, this J unit is what? Remember here J, na? So J will come in numerator. 4.18 joule per calorie. Right? Like this. Okay? Now what should I do? This side if I talk, this is calorie already. I want to convert this joule into calorie. Right? So should I multiply with this J or should I divide with this J? What do you think? This side I should divide or multiply with this J. How many say divide? That's it. Multiply. I will leave the class. I'll sleep in my room. Done, chapter completed. See here, this is joules, right? I want here what? Calories. Because that side calories is there, right? Okay. So, his unit is what? Joule per calorie. If I multiply here joule per calorie, right? This is joule square by calorie. That is not good, right? Okay. So once if I try with divide what? Joule per calorie. Now joule cancel out, calorie numerator, right? So it is good that if I divide with this number J here, okay? Or if you talk this side, so this side if I divide here joule per calorie, then it will come what? Calorie square by joule. That is not good. So here you multiply with J. So joule per calorie will come, calorie cancel out, joules, this side. So either you divide this side or either multiply this side. Okay. So relation came what? mv square by 4 is equals to msj delta t. Can you answer delta t from here? Right? I think that only is asking. M cancel out. Okay. So here you have 1 meter per second. Okay. And here you have what? 4 meter per second. Okay. Gravity is how much? G 9.6 by 2. Okay. I think like this he is writing. Okay. Basically what happened is that gravity was 9.8 only, but some air resistance is there, so net force is 9.6, like that maybe he wrote. Okay, I don't know exactly. So acceleration came, initial velocity, final velocity, acceleration, you know, it's a constant. So what we can apply? Equation of motion. Which one we will apply? Three quantities we know, V, U, A. So apply. Okay.